Hello everyone, here we are very glad to present our work, a system for depression detection in social media. We call it BlueMemo. As we all know, depression has become one of the most common mental disorders. It has affected more than 300 million people around the world. The process for depression detection is very complex, and it is difficult to diagnose depression at the very early stages. Social media, like Twitter, Facebook, contains billions of users' data. It allows users to freely express their feelings and emotions. Can we take full advantage of such data to detect depression? So in this work, we design a system for depression detection using data from social media. We have several motivations to implement this system. First, we would like to early detect the depression, which is helpful for depression treatment. The second is accurate prediction of depression. It is also important for depression treatment. The third is taking full advantage of social media data to detect depression and to address the problems of traditional depression detection methods. Here are also several challenges. First, the expert knowledge is a big challenge for us. The traditional approach of depression detection requires experts to diagnose a mental disorder. Can we use social media data to accurately predict the detection without expert knowledge? The second, social media contains huge information like billions of text, images, videos, and so on. How to effectively use this huge amount of information to design our system is also a challenge. The third challenge is multimodal information learning. How to effectively combine these different kinds of information is a challenge. The last challenge is how to build an effective system to accurately and rapidly detect depression. Our solution is illustrated in this slide. We acquire data from Twitter. It contains users' tweets and posted images. Then, based on this data, we extracted textual features and visual features from the two kinds of data. After that, we combine the two kinds of features and train a classifier using a deep neural network. Finally, the depression and non-depression users can be classified by using the whole system. The framework of our system is like this. The first part is data collection. We built our dataset using the data from Twitter. We acquire the users' posted tweets and images and split them into training and testing datasets. The second part is feature extraction. We use posted tweets and images to extract 3 different features, including textual feature, image multi-label features, and visual features. We design a CNN-based multi-label classification model to get image multi-label, then use BERT model to convert multi-label text into textual multi-label feature. We also use color processing techniques to extract visual features, including the color features in RGB and HSV color space. The last part is feature fusion and classification. Based on the extracted features, we designed a deep multi-model learning module. We first do feature fusion to generate more robust features. Then we build a classifier using low-rank tensor-based deep neural network to accurately classify depression and non-depression users. So that's the technical architecture of our system. Now let's go to our BlueMemo system and see how we complete our assessment of a single user's risk of depression. On the main page, we can see that the whole system has 2 major functional blocks. On the left is the setting module, which is used to set the user's scope, including the input ID and the user's range for training. At the top of the page is the main function module, which is used to preview the social media page of the user. Preview the text and images posted by the user, observe the analysis of relevant characteristics of the user, and finally evaluate the depression risk. Now let's click the Start button. Once we have entered an user ID and set the detection range, we will go to the page under User tab. Here we will see the user's home page preview, the user's media page preview, and the user's likes page preview. In order to protect privacy, the preview here and the user's information in other parts of the system have been blurred. Click Next and we will go to the page under Post tab, where BlueMemo will show us the posted text and posted images used in the training model. Click Next and we will see the page under Diagnostics tab containing 4 display areas. The area under the top left is used to display the user's visual word cloud. It will help the psychologist quickly understand the keywords most commonly used by the user, which will facilitate the analysis of user language characteristics. The area in the upper right shows the risk of depression as measured by years. More specifically, we can also choose the risk assessment value obtained after training the model in either single-mode text or image. The area at the bottom left provides a special function for a psychologist, which is to trace back to the time when the user's depression was first established. Here, a time curve is used to show the user's depression risk values at different times, and the time when the threshold is first exceeded is regarded as the time when depression is first discovered. This is hard to trace in a traditional diagnosis of depression. In the lower right corner, we will present a curve drawn by the visual feature we extracted, which shows the color features in HSV color space of the image posted by the user. On the final outcome page, we show the trend chart of the total number of posts for the selected user. Another key statistic is shown in the lower left corner, which is the numbers of visual features appeared in the posted images. The lower right field shows the final depression risk assessment, with the mean value of all users for each modality as a reference. All the above analysis data can be generated in an analysis report using the download button on the left for system users to download.